So here we look at an example of how the skill of forming equations is applied to two examples. We'll start off with example one, which is a rather straightforward question. So reading line by line maths, the diagram shows a solid hemisphere. Can't do any maths for that. Move on. Second line says the volume of the hemisphere is 250 over 3 pi. At this stage, they've mentioned a keyword volume, and the volume of this hemisphere they've given us as an answer is this value. So the skill of forming an equation is to use that keyword and that answer to form an expression or equation related to that. So we know how to form an equation for volume of a hemisphere, which we will go and do now. So volume of a hemisphere is equal to a half times 4 over 3 pi r cubed. We formed that despite them giving us this answer. Often students just think there's an answer here, so let's move on. No, we need to tell them we stop here and we're going to form an expression or an equation for this volume in order to then equate that expression to this value because they are both equal values. So we can put an equal in between them. So this then gives us 2 over 3 pi r cubed. It's the volume of the hemisphere. We know what this is equal to. The value of this volume of the hemisphere they've given us is 250 over 3 pi. So we will then write that down, 250 over 3 pi. So this is the skill of forming the equation where they have used this expression here, which is for the volume of an hemisphere. And this answer, which was given to us in the question, answer or value of volume of hemisphere. And since we are talking about the same thing here, we can then say they are both equal to each other, hence creating the equation, which you would then go and solve. So that was example one. I'm not continuing the question. They would have to go and obviously solve here to find R. And once they've found R, they can then tick that line off. And then using that R, we would then go and attempt the second line, which talks about surface. So we would set up an equation for surface area and use what we know. Right, moving on to the second example, slightly trickier one. It starts off by saying the diagram shows a sphere and a solid cylinder. The sphere has a radius of 6 centimeters. We understand that, we can see that on the diagram, no maths to be done at this stage. The solid cylinder has a base radius of 3 centimeters and a height of h. Again, we can see this on the diagram, can tick that off. Then it goes on to say the total surface area of the cylinder is twice the total surface area of the sphere. At this line we stop and we focus on this here, the total surface area of the cylinder and the total surface area of the sphere. And we're going to go and do the maths for this. So we'll write down an expression for the total surface area of the cylinder. So let's start off here, cylinder. Surface area of a cylinder is first of all the two circles at the top and the bottom, so that's pi r squared plus another pi r squared. So circle at the bottom and circle at the top, plus the curved surface area, which is essentially the circumference times the height. So that's 2 pi r circumference times height. If we tidy that up, that's 2 pi r squared plus 2 pi r h. And we know certain things about this cylinder. We know that its radius is 3, so we can go and put that in. 2 pi bracket 3 squared plus 2 pi bracket 3 h, which we don't know. Tidying this up, we get 3 squared is 9 times 2 is 18 pi plus 6 pi h. So that's the surface area of the cylinder. Now, even though it says twice, the surface area of the cylinder is twice the total surface of this sphere, we're not going to just go and double or half one of them. We're going to then go and form another expression for the total surface area of this of the sphere. So now I'll write down here sphere. Surface area of a sphere is equal to 4 pi r squared. And we know the radius of this sphere, so we can put that in 4 pi 6 squared. So then we get 36 times 4, which is 144 pi. Oh, sorry, made a mistake. No, that's fine. 4 pi r squared. That's fine. 144 pi. So at this stage, we've just found the total surface area of the sphere and we found the total surface area of the cylinder, but we need to use this information. And this is where students often make the mistake here, forming this equation. It says here that the surface area of the cylinder, so I'll write this here, surface area of cylinder is twice that of the surface area of the sphere. So I'll write down here surface area of sphere. Let's understand what this line is saying. If the cylinder is twice that of the sphere, surely the cylinder must be bigger surface area. And this must be smaller. So if the surface area of the cylinder is bigger, then how can we make them equal? How can we form that equation? And this is where students often make that mistake. They put the times 2 on the wrong place. And this is probably the best way to explain this. If the surface bigger, which we can understand because it's twice as big, then to make them the same, surely we must double the other one, the sphere. If we want to put an equal in between them, suggesting they are both equal, then surely we need to have the surface area of the sphere times 2, because that's the smaller one. So the smaller one would have to be times by 2 in order to make it the same as the cylinder. So get them to form the word equation first, and then we can write down what we know. So what's the surface area of a cylinder? Well, it's 18 pi plus 6 pi h, and is equal to surface area of a sphere, which is 144 pi and times 2. That's the forming the equation using this third line here. From here we can see that we can tidy this up a bit. 288 pi is equal to 18 pi plus 6 pi h, and we can see here there's an unknown here, h, so we would solve for h and then carry on with the rest of the question by doing line by line maths. So you've seen in both of these examples how we form equations by finding two things which are of value and then putting an equal in between. In the second one, we had to times one of them by 2, the smaller one, in order to make the two values equal, so we can actually put the equal in between.